Hello everyone, welcome to the Backend-less Development Revisited talk. In this session we're gonna discuss how we can make front-end development independent on backend related issues. So let me introduce myself. My name is Tomasz Ducin. I've been working in various technologies, and a couple of years ago I have fallen in love with JavaScript and its ecosystem, and this is what I do since then. And I'm doing trainings, and on a daily basis I work for a Cybercom Poland company where I try to design architecture and develop enterprise-scale interfaces. For less than 3 years I've been working for a financial sector, precisely doing banks. And the experience I gained throughout this time is what I'd like to share with you during this talk. So what we're going to talk about is, in the very beginning, I would like to briefly recap what is single-page applications approach, where did it come from. Then we will get to the main topic, which is backend-less development. What is this? Why do we need it? Where we might use it? Then we'll discuss how it works technically. We'll see the example implementations in Angular.js and in sinon.js. And finally, we don't want to do things manually, so we'll briefly cover automation of this thing. Okay, so let's get it started. For the web is here since quite a few decades, and the traditional approach that we've been doing web pages is that the client was shooting a request to the server. The server was processing all the stuff, so it was including backend database calls, any kind of processing, including template rendering. It was building some kind of a big package that was including HTML, CSS, JavaScript, assets, and so on. And it was just moved up to the client, and the page was somehow, let's say, static. It was just residing in the browser, and it was disposable. So if we clicked a link, or if we just shoot another, let's say, form submission request, there was a page reload, right? The server had to do all the stuff again, including template rendering, including just shooting, just sending all this data back to the client, right? So this was disposable. The first question of today is, how do you think, what were the problems with this approach? What is wrong with it? Yes, transfer overload is one thing, because if we send HTML, CSS, and JS all the time, then the HTML is, of course, including all this HTML boilerplate, then the response is just big. What else? Once more? Yeah, exactly. What else? Performance, time response. So this is quite general, and precisely what the backend should do is more about, let's say, handling data, and it's not necessarily about the presentation layer, right? So basically, here the server had to do almost everything, package and bundle everything, just send it to the browser, and the client was not, capabilities were not utilized that much, right? Yeah, so these are the problems with this approach, and basically server-side web applications is something we don't necessarily want to do anymore, right? And for these reasons, some people came up with the idea of single-page applications. So it starts the same way, basically. We just shoot a request to load the application, and the difference is what we have loaded, the HTML, CSS, JS, of course, this is a simplification. It stays in the browser, right? It stays, and there is no page reload. So basically, when we want to load another, let's say, sub-page, or we want to create something, update, delete, whatever, we just shoot a request, and the server is just processing the data, the logic, right? And it just handles, let's say, creation, retrieval, update, or any kind of the logic the application is performing, and it's just returning the JSON. Of course, it might be different format. It doesn't have to be REST API. It might be quasi-REST. It might be GraphQL, whatever. But basically, this is the idea that there is no single application from now. It's separated, right? The server, the REST API, is a separate application, and the client is also a separate application, right? And this solution seems to solve all the problems that we have mentioned before. This is something that we want to work right now. And actually, when we do new projects, everybody is talking about single-page applications like if it was some kind of flawless solution, right? But the thing is, always when you benefit from something, you never get it for free, right? There is always some cost for that. And like in other words, there is always an issue that you might introduce at the same time. And I would like to tell you a short story about that. So, once upon a time, there was a team of software developers. There were the cool kids on the front. They've been doing good look and feel, responsive web design, user experience, and that kind of stuff. And there were the respectable gentlemen working on the backend. So what they've been working on is data persistence, scalability, transactions, and that kind of backend-related stuff. And they believe that what they do is important for the system. And you might have noticed that there is a guy over here, a special guy, that was working for the company for a very long time, working for the same project for a very long time. Actually, he was afraid to leave the company, right? As people were moving in and out, he has gathered all the secret knowledge about the system. He knew everything about magic numbers, everything about dirty hacks inside the system. He was a perfect guy to ask about some crazy stuff. So he was a perfect match for a solution architect. And due to the fact that he would never leave the company by himself, he became one. So it was just an ordinary day. The guys were just doing their stuff, and suddenly the backend broke. There was just a service deep inside the backend which just stopped to respond. So at first, one of the backend devs tried to restart the service. And it went down again. So he tried to restart it several times, and it was just going down over and over again. So he asked his colleagues for the help, but they were not able to help. So they thought that this is a severe situation, a critical one. So they grabbed their fire helmets, turned into a team of firefighters. They were running over the office, trying to find anybody who might be able to help, including the solution architect. And in the meantime, the front-end guys tried to do their job. They were trying to access the data from the backend, and it didn't work, right? Request was shut, and there was just no connection on the other side. So they waited until the solution, the problem is solved. So they waited, and they waited, and they waited, and nothing was happening. And so they thought that they might play table football or any kind of activity like that. Maybe when they finish, the problem will be solved, but it was not. And the day was over, so they went home. So they were not that stressed as these guys. But actually, this is quite a sad story for the company that they've been working for. And the story is about tight coupling between the front end and the back end, right? Tight coupling is a term that we often use in terms of design patterns, that something is tightly coupled, which just introduces more problems. If we take a look at architecture level, we can see that it works exactly the same way as with design patterns. So we can see that the backend can work without front end, but the front end cannot work without the backend, right? A tight coupling example. So my question to you is, what is more important, front end or the backend? Go on. Front end, equal. Both. Any other opinions? I'm pretty sure you do have some. It depends. I know this is a biased question and it's pretty lame, but actually if we think about it for a while, we can see that if there is some kind of internal company force that makes backend the more important, which makes frontend suffer, actually it makes both suffer, right? Because if frontend development is somehow disrupted, it cannot be done, then the whole project is not delivered, right? So it's not only a technical problem, but it's also an organizational and business-wise problem. Let me tell you another story. The solution architect, it's on that side, thought that the JSON response for a given resource is just wrong. It might be better. So he gathers his colleagues, he holds a meeting, and he says, let's modify the JSON response. They ask, why do you want to do it? And he says that just his new idea fits the resource better. They discuss it, and actually they think that he is right. And that's cool. They discuss what is going to be the new shape of the JSON, they implement it, and finally they deploy it. And what happens is the application stopped work. And what is the problem? The JSON was wrong? No, yeah, the contract was not matched because basically they discussed what is the current response, what is the future response, right? But nobody told front-end developers that they should adapt. How many of you have experienced such situation? I can see more than half of you have experienced that. Yes, this is a very frequent problem. It's not a technical problem, it's just we call it bad communication inside the team. So these are the issues that backend-less development tries to address. So what is actually backend-less development? I would say that this is an approach to develop front-end, that develop clients without having backend at all. It's not about production environment, because in production environment, if you don't have working backend, then working front-end will give you nothing, right? So this is just only about the development phase. So backend-less development is the ability to develop front-end completely independently. And from my experience, I have seen that 90% of my work is just doing the actual development, and 10% is doing the synchronization between front-end and backend. So let me explain that briefly. If we try to make if we do the backend, make the backend the more important one, then the frontend needs to adapt, right? So whatever change is made on frontend, on backend, then the frontend is pretty doomed because it has to adapt very soon. So the solution is that whenever we are given a new feature, a new project, both front-end and backend people meet, they discuss what needs to be done, they design a contract, as a colleague has said already. So they define the communication. What kind of resources we have, what kind of data is going to be sent as the request, what data is going to be responded as the response, and so on. So basically, they define the contract, they define the communication, and at that point, they can spread. Backend can do their work independently, and frontend can do independently as well. So basically, what we do is that 90% of the time, provided that we do have a contract already, we can implement the whole solution, right, without having backend at all. In the meantime, parallelly, the backend guys are creating the backend for the solution, and the 10% of time is just spent to synchronize them, right? In perfect world, it would be 0, right? Because everybody would stick to their contract, but this never happens. So basically, it's just things like camel case, uppercase, lowercase attributes, just making sure that the contract is the same on both sides. So by this time, when we don't have a front end, what we benefit is that, for example, we can display our application to the business representatives. They are able to see the application. They are also able to click through it just to see that if you push a create button, then you will have a pop-up. You will fill the form. When you click save, then something will reload, and you will get a new list of items with the new as well. So they can see all this. They can react to it. They can say what they want to change afterwards, right? So basically, this is backend-less development. Don't confuse it with serverless, which is a completely different thing. And yeah, backend-less development avoids such situations like who changed the API response structure. Okay, so backend-less development is based on mocking the API. So it's providing some kind of fake data source. So the question I want to ask, another question, is what layers do you think might fit to be mocked? So going from the bottom, database. We know what a database is. I don't cover it in this presentation. One level up, we've got server API endpoint. So basically, whatever this is, whatever technology it's implemented in, this is the endpoint, HTTP endpoint that we talk to. And we expect the responses to be returned from it. Browser API is just whatever technology you have implemented in the browser. So it would be basically built-in JavaScript. At this point, we've got framework, so it might be Angular.js, React, jQuery, whatever you use here. Application core. Most of the times, we do have some kind of shared functionality inside our system. So this would be the things you reuse throughout the system, like authentication and that kind of stuff, like pop-up windows, model windows and the things. And the application modules. For instance, list all the customer, comment on a blog post, and this kind of domain-specific features. And finally, we've got the graphical user interface. So this is all the buttons, the clicks, the scrolls, so everything a user can actually touch and interact with directly. So the question is, if you want to mock, which layers of these do you think make sense to be mocked? Server API, yeah, definitely. Of course, you can mock a database as well, but this is like outside of the scope of this presentation. What else do you think makes sense to be mocked?
Application core.
Application core. Any other ideas? Come on, don't be shy. Nobody? Browser. Yeah, anything else? Okay, so in my opinion, it makes sense to mock 3 layers of these. So basically, a framework often comes bundled with a feature that we can use to mock the API. For instance, in Angular.js, we've got HTTP backend service, which allows us to mock the backend. So basically, when the user clicks something, this request goes down and down, and when it reaches the layer that is mocked, it just goes aside. It fetches the data from here. It simulates the processing on that part. It goes back, and it goes up. So if this layer is mocked, then it just doesn't go down, right? And the same way for the browser API. So the request comes here, it goes through the framework, we mock on the built-in JavaScript layer, we go aside, we fetch the data, and we come back. And the same story with the server API endpoint. Okay, so we're gonna briefly discuss the 3 of these. Of course, we could do this on application core, but I don't think if it makes sense if we can have either of these things that somebody else wrote for us. Like we can do it manually, but I don't know if it's worth. Okay, so a little bit of business background. So why would I need backend-less development if I've got a backend anyway, right? So let me share a little bit of my experience on that topic. The project I've been working for over 2 years is called Portal Bank. So it's an end-user interface for bank customers. It's been shipped in over 120 Scandinavian banks. It took us over 1 year to reach production. It's an Angular and TypeScript-based application. And basically, it replaces old-style Java server pages application. So just the traditional web pages is thrown out, and we reintroduced Angular-based interface. And we do backend-less development a lot. Actually, we would not be able to ship anything in the new architecture if we didn't use the backend-less development. And this is because bank is an enterprise environment, and it's quite specific, right? In enterprise environment, we've got problems that do not exist in normal environments. So let's talk about this a little bit. Can you see what the guy in the picture is doing? Yeah. As most of you probably know, there is a phrase in Polish, to paint the grass green, and it means to perform some actions that don't provide any value at all. And this is what we do in enterprise, basically. And regarding Zach's talk, nobody gets fired for this. This is a miracle, wonderful job. So you can do that individually, or if you prefer, you can do it in teams, right? It depends on your organization whether it prefers individual experts or Scrum teams. And I mentioned that we have some kind of specific enterprise-wise problems. So the most important of these are budget-driven development. Budget is a limited amount of money that might be spent in a limited amount of time, right? To gain some specific benefits. So basically, if you are given 3 months to complete a project, and you have to wait 2 months for the backend to be hardly available, and that might not even happen after 2 months, then 1 month is not enough for a frontend to be done, right? So you have some options. For instance, you might just hard code JSON responses inside your code, which is pretty bad because when the backend is there, you would need to refactor everything and just throw it out, right? Another problem is that in big companies, in big teams, we can have distributed teams as well. So not only you don't work in the same office, in the same city, in the same country, but you might even work in different continents, right? And this means different time zones and different working culture, right? So it may happen that you're doing a front end and somebody on a different continent is doing the back end. And the question now is, how can you successfully and efficiently communicate what is going to be the communication layer, right? What is going to be the request response shape, like when is something going to be delivered? So these are problems we face. And of course, backend unavailability. By backend unavailability, I mean not that you just can deploy your backend locally, because a backend is just a black box, but usually it's just many layers. So you can have quite deep, a service quite deep that is just not responding. So everything that is built on top is failing, basically. And you never know when something is going to fail, and it might take up to 3 days until it's fixed, and you never know when it happens. So there is quite a lot of time loss during development. So to recap, from technical point of view, we've got tight coupling, right? Frontend is tightly bound to the backend. When the backend is down, frontend has problems as well. And from the business point of view, we want to address backend unavailability. We also want to address a situation when backend is about to change something, and such change is forcing a change on the backend, as well as the need that the backend needs to be done prior to frontend, right? If we don't mock our backend, then we need to wait until the backend is done so that we can just start with the frontend, right? So these are the, let's say, business-wise problems we want to address with backend-less development. There is also one thing about testing. If we want to test our interface in E2E tests, who knows what is E2E test? Hands up. Okay, so there is some people. Just to quickly explain, unit test is just testing a single unit of code, just in an abstract way, whatever it's going to be used in. And E2E test is just testing the interface, so that we simulate that we click on a button, we expect a model window to open, we fill the form, when we click save, we expect that the list is reloaded. So we are basically testing the entire interface behavior, right? We don't test code, we test entire interface. So let's say that we have our interface, we build it, and we want to test it. And the question now is, what is this interface going to talk to? Of course, it has to talk to some kind of API. And if we do have a big and complicated backend system, it might take us quite long until the backend is built and it's deployed, right? So in my case, it takes up to 1.5 hours or even 2 hours for this guy to be ready. So if I want to test only the interface, right, not the integration, only the interface, I might just use my mocks to test the behavior of the interface. So this is another more technical case. Okay, so going to more technical details. The backend-less approach consists of delivering data. So as we already said, we can have 3 different layers that we just provide the data. But most of the, let's say, fake servers that respond the same data for the same type of request are not really useful. For instance, if I shoot /customer/1/customer/ let's say 17, and it always returns the same data, it's not very useful. For instance, if I want to test creating a new, let's say, element, and I want to see that it has been already created, I need to have dynamic mocks. I need to have dynamic data. So we would like to add mocking backend behavior as well, right? So all this logic inside backend is also simulated, not only the response shapes. And finally, we can have some automation and some organizational stuff improved as well. So we can use JSON schema, and we can use API contracting, and we'll cover that in a while. So first of all, when we mock our backend, we can just return data as is. So this is quite simple, but we can also simulate the response timeout or delay. So when we have real applications, it might happen that we can have race conditions in our front-end application, and we don't know until such situation happens, right? Because we expect that the first response always returns data after, let's say, half a second, and the other one is always longer, let's say 2 seconds. And we don't even test this. Having response timeout delay, we can just define what is the delay for a given mock so that we can test all the combinations. Another opportunity we get is that we use JavaScript functions to do all this mocking behavior, so that we can use basically function parameters. So we can use the information, whether it's a get, post, put, delete method. We can use all the parameters like what is the ID that was passed inside the URL. We can randomize the responses if we want, and we can do pretty many more things depending on the tool. Let's go further. JSON schema. JSON schema is, who knows what JSON schema is here? Okay, so it's quite few people. Basically, JSON schema is a JSON definition for what other JSON documents might include. So it's like XSD for XML, it's like JSON schema for JSON. So we don't want to create our JSON files, the mock data, ourselves, because it's just time consuming and it's like very expensive to maintain. So we want to automate it, and we use JSON schema for this. So here we can see an example JSON schema document. So we see that this is going to be an object, and this object will have 3 properties. The first name property, which is a string, last name property, which is also a string, and an age property, which is an integer that minimum value is 0, and we have a description here. We also define that first name and last name attributes are required for this, for all the JSONs that conform to this schema, and that additional properties are not allowed. So basically, this is just a JSON file, just a JSON document that defines what are the other JSONs might include, right? And example JSON that specify that conforms to this schema is first name John, last name Lennon, age 40. And another one is first name Paul and last name McCartney, right? So using this schema, we can use also tools that will just automate generation of data that conform to this. And an example of a tool that does this is JSON Schema Faker is a project that based on Node.js that just gets such schema and produces fake data for you. And this is domain-related data. So you can say that something is a name of a human, something is a name of a company, name of a street, name of a country, and so on. So you can just generate it. And why is that useful? Because if you want to test performance, then you would like not to have 3 objects, but you would like to have, let's say, 3,000 objects. And at some point, you would like to extend your object with a new attribute. So you will not go through all those 3,000 objects, but you would like to have it automated. And basically, this tool does this job. Another thing is API contracting. So another words, contract first design. So basically, before we do anything, the backend and frontend people meet. They discuss what is the contract that they agree on. So basically, they define the URLs that are going to be available in the API, that define HTTP methods, so get, post, put, delete, that kind of stuff. HTTP status codes, so 200, 404, 401, 403, 500, when do they happen and what does that mean? Content types like JSON, HTTP headers, if we create any kind of custom headers for our application, and finally the content itself, so JSON schema that we have just defined before. So a contract is just a document, right? A document that we can write down. And from this moment, backend is not the most important one, and frontend is also not the most important one. The contract becomes the most important one. Frontend has to adapt to this contract, and backend needs to adapt to the contract as well, right? So if we have any changes in the project, we include it in the contract, and both sides need to adapt to it. And this requires that the front-end and back-end developers will talk to each other, right? So this reduces some of the problems we do have already. Such contract is just a text file. It's stored in the repository, it's available in the continuous integration environment, and it can be used for various automates, including documentation generator, automatic tests for the backend, and automatic mock generation, and that kind of stuff. So, contracting tool stacks. So we've got API Blueprint, Swagger, and Ramel. I think that you might have heard about some of them. So basically, they implement the same idea, they just use a different syntax. And each of them has some kind of different tools that implement documentation generation, data generation, fake server generation, and that kind of stuff. Okay, so now we'll go through all these three layers. So basically, the server API endpoint is something that is probably the most obvious for you. Like, instead of having a real backend, we can just create a fake backend and use it for the development purpose. So we can do that either manually, or we can use one of these three, Swagger, Ramel, or API Blueprint, so that we just use the contract file, the contract definition, and everything will be automated for us. This is one solution. But this is probably the most popular and most known for you, so I'm not gonna cover this very much. More interesting thing is browser API mocking. An example tool that does the job is sinon.js. Is there anybody who knows sinon.js here in the room? Okay, there are a few people. So it's a tool that makes it easier for us to test, basically. It provides some assertions and some kind of spy and stub features. And also it provides a feature that is called a fake server. And the fake server is using the built-in native XML HTTP request object. And basically, this object is something that every browser has. What Sinon does is that it just creates a fake implementation and replaces it, right? So when you try to shoot an Ajax, whatever library you're using, it's gonna take the fake. And the fake will just utilize the functions that you have defined. So we go this route, grab the data, and go back. And we can also get back to the native implementation. So basically, the fake server is just put aside, and the original object is back. For this, I don't have enough time to demonstrate, but there is a project with a minimum amount of code that you can see, and there is also a online demo that you can see just how to get it started. I'll publish the link to the slides after the presentation. So take a look at the code for a while. So in Sinon, basically, we create the FS, the fake server object. It has many methods, but the most important of them is the respond with method. So basically, it accepts the HTTP method, so either get, post, put, delete, whatever, and the URL, which might be a regular expression as well. So basically, when this fake server object recognizes that there is a request that is shot on a specific URL and a specific HTTP method, it will recognize that it has to return some kind of static data that we have here, right? So we know that for a given URL and HTTP method, we will return a triple that contains the status, the headers, and the data itself, so just the JSON value. And this is an example of what we can have in JSON. So at the top, we've got some kind of value, just some static data. So we have Sinon fake server wrapper. It has init and restore methods. So we create the server here. We call the respond with method. So when we have get customers, we respond with 200 OK status, content type application JSON, and basically we stringify the JSON value. And that's all we do, right? From that point, if we do have this code in the browser, no Ajax is going to be shot. Nothing is going outside the browser. So this is the the simplest example you can have. Another solution we can use is if we mock on the framework level. So in Angular, we have something that is called HTTP backend service. So we don't alter the built-in JavaScript objects, but the logic is very similar. So basically, we have the when methods. We can have when get, when head, when delete, and so on. So basically, we also define the URL, we define the method, we define the data, and also we can define the headers. And just as in sinon.js, we respond with a triple HTTP status, data, and headers. As you can see, the order is different, but the logic is exactly the same. But what we can do is that we don't necessarily have to respond with something that is static, right? We can respond with something that is dynamic. So we don't respond with a triple, we respond with a function that has all the parameters about the request, and we can do the mock behavior here inside the function. So return HTTP status, data, and headers here. So here we would have the URL available, the method available, all the URL parameters, and so on. So we can use it for the processing inside of the function. Yeah, when get, when head, when post, put, delete, and so on. And take a look at this example here. So this is just some Angular boilerplate that is not really important at this point. And we've got the mock part. So let's say that we've got some data here. We do the magical 4 lines that we have to do and don't care about that. And for a given Angular module, we write the run phase that has HTTP backend when get. When we shoot /events/6, we respond with data, 200 OK, data, and let's say header 1 if you want to. Of course, we can have this as a regular expression. We can react to this value here. So basically, this is the basics of the implementation of backend-less development. And let's go to mock automation. We don't want to have all this thing written manually, so let's cover this one. This is a simplification. Let's say that our entire application is available in the app.js file. And the idea we might use, and that is pretty useful, is that we can define all the mocks inside one file, that is mock.js. And now, if we include the mock.js file, then the whole API is going to be mocked. If we don't include it, then we just talk to a real API, right? And we use including or not this file as a, let's say, build process parameter. Either build the application on mocks or not. So we will see how we can achieve that. So we need to build this mock.js bundle. And in order to achieve that, we need to do three things. First of all, we need the mock data. So we need to get this JSON stuff ready. So we can do it manually, we can use JSON schema, we can use the API contracting tools, whatever. So this is one thing. The second thing is mock logic. So basically, we would like to make those mocks intelligent, so that if we create a new object and we shoot a get collection, we would like to receive a collection with one more element. If we delete something, if we update something, we would like to have updated data, right? So we create a set of functions that we want to support for a given resource. So not only mock data, we also include the mock logic, mock behavior. And finally, the dependencies. So it might be a fake server for sinon.js, it might be HTTP backend for Angular.js and whatever tool you use. So just the core engine we use here. And we need to get those three things built into the mock.js bundle. So in order to do that, the question is how we can combine that stuff. Let's say that we have a JS file that is requiring, here it says require B and require C. So basically, we have a dependency in a JS file to a file B.js and to file C.js, right? And additionally, the file B.js has a dependency on a file D.js. So let's say that all these files is just we could have a lot more of them. Some of them might be the mock logic, some of them might be just the mock data definition. So we'll have many files in our system that reflect the mocks, and we want to just put them together into one file. So basically, what we do is we want to bundle them into one file, and there is a pattern that is called abstract syntax tree. So basically, we give one entry point, and there is a tool that understands that it needs to parse the content of a file, go through all require statements, and build a tree of the dependencies basing on it. And when the thing is done, when there are no cycle dependencies, we just create a bundle output. And the tools that implement this is either Browserify or Webpack. I think that some of you might be familiar with them. So basically, they base on the native require function that is available in, for instance, Node.js, and is also somehow interpreted in the browser. And using some loose files that we have, it will just build a bundle. So basically, those three things that we have, so it's mock data, mock logic, and the dependencies, will be just bundled into one file. This is pretty easy stuff to be done in Node.js. So we've got all these things built into mock.js. We automate it using Grunt, Gulp, Webpack, whatever kind of automation tool we use for our frontend. So basically, we enable the developers to add such option in the command line interface, whether we want to work on mocks on a real or on a real backend. So when do you want to work on mocks? First of all, when we develop, we don't want to deploy our server because it takes time and it just might fail or for whatever reasons. And we want to build mocks when we want to do end-to-end testing, but testing the interface only, right? Testing only the interface behavior. And we might want not to use mocks, and this is when we want to test the end-to-end integration, and when we want to go to production, right? That is quite obvious. So basically, this is how we can design and automate this entire approach. So if there is one thing that I would like you to remember after this presentation, is that when we make one of the sides more important, then actually we make both sides suffer from it. But if we make both sides independent, then entire system is going to benefit from. So this is all I prepared for today, and thank you very much. I don't know if we have time for questions. Maybe some. If there are some. Yes, there is a question.
Yes, if you have to choose to implement end-to-end or unit tests, only one, what would you choose?
The question was, if I were to choose between either having only unit tests or only end-to-end tests, which one would I choose? So this question, I would say, goes down to if I were to choose either I have both legs or both arms. It's difficult to live without any of them. So basically, unit tests serve different purpose, and end-to-end tests serve different purpose. For unit tests, you can find out that a very small piece of code is valid or invalid. And for end-to-end tests, they can answer the question that something is wrong somewhere, but you don't know where. So if you want to create successful applications, I would say you need both. And if I were to answer which one of these I would have to, which I would prefer to have, I don't know. I would definitely like to have both. Like, it doesn't make sense to have 100% coverage, but I would just use both. For instance, you might have end-to-end tests that do smoke testing. Smoke testing is just a very simple end-to-end test that if there is just any kind of core functionality that is broken, the test will fail. So for instance, you do some kind of refactoring, and if a critical thing is invalid, then you know it. And this test is really cheap to create and really cheap to maintain. Hope that answers your question. Any other questions? Yep. Okay, so I'm available at the conference, so hopefully talk to you soon, and thank you again.